Hello and welcome to this video. We're going to be taking a look at building VR games in Unity, where we look at how to set up the editor for VR development, installing the XR Interaction Toolkit, and some common practices and techniques that are going to assist you in your VR game development journey. This video is going to assume that you've got the Unity Hub installed and you're all signed in, and you're ready to go ahead and click on New Project. I'm going to be using the latest LTS version, which is currently 2022.3.22F1, but that may be different for you by the time you get to watch this video, and that's okay. There is a VR core template that you can use, and that's all set up and ready to go for you, but we're going to be using the 3D URP template so we can see how you can set it all up from scratch. Don't have that yet, so I'm going to go ahead and download it. I'm going to give my project a name. I'm going to call this Creating VR Worlds. Give it a location, an organization, and go ahead and hit Create Project. So I'm going to go to my project settings, and if you haven't got this already, you can go to File, Build Settings, and then click on Player Settings. At the bottom of the list, we've got XR Plugin Management. I'm going to click on Install XR Plugin Management. If you click on it again, you'll see we have our build targets across the top, and we have our plugin providers in a list in the bottom. If you don't see your build target across the top, then it just means you need to install it through the hub. So going back to the hub, you click on installs and you find your install in the list. Click on the cog and then add modules, and then you can select what additional modules you would like to install. Once they're installed, you can go back to Unity and you'll see under XR Plugin Management, your target is available across the top. I'm going to be testing this in the editor, and I'm going to be testing it on a MetaQuest 2. So I could choose either Oculus or OpenXR. In this case, I'm going to go for OpenXR. And whether at this point you select OpenXR or Oculus as a plugin provider really depends on your specific project needs. OpenXR is designed to be a universal standard for virtual reality and augmented reality. It supports a wide range of devices across different platforms, and that makes OpenXR a great option for developers aiming for broad compatibility and future-proofing their applications. So I'm going to go ahead and choose OpenXR. And then once the project has restarted, you see the project validation window has opened up, and we got a couple of warnings. One's the interaction profile, which I'll talk about in a minute, and then the other is about switching to XR pose control instead of OpenXR pose control. So let's go ahead, we'll hit fix all, and the editor's going to take care of this for us. We've got one left here, and that's our interaction profile. That's one we can do. It's super easy to take care of. We're going to go to our OpenXR, and we just need to tell the editor about our interaction profiles. An interaction profile within XR Plugin Management refers to a set of configurations that define how input devices like controllers interact with the virtual environment. So we need to tell it what controllers we're going to be using. So we're going to hit the plus and select the Oculus Touch controller profile. As I mentioned, I'm using the MetaQuest 2. So that's the Windows, Mac, Linux settings taken care of for if I want to play it in the editor. When I want to build on my device and I'm using the Android settings, I'm going to need to just do the same as well. So make sure I've got OpenXR selected, and I'm going to put an interaction profile here, exactly the same, Oculus Touch controller profile. Back in XR Plugin Management, also going to make sure that on Android I've got OpenXR checked. This video is going to utilize the XR Interaction Toolkit package from Unity, and that is available through the Package Manager, which we can get by going to Window, Package Manager. We want to select the Unity registry, and we'll start typing in the search box, XR Interaction, and you should see it pop up. You can think of the XR Interaction Toolkit as a framework designed to simplify the creation of VR and AR applications. That gives you a set of tools and components for handling the common XR functionalities, such as interacting with objects, navigating around the VR space, and UI interaction. So we're going to go ahead and install this package. Additionally, with the XR Interaction Toolkit comes some samples. We're going to use the starter assets, which contains a set of input actions, and also a great demo scene that we can take a look at. So we'll go ahead and import the starter assets. And lastly, we'll be taking a look at the XR Device Simulator. And this is great for VR developers because it allows you to iterate faster, because you don't have to keep taking the headset on and off to just quickly test something in play mode. You can use the XR Device Simulator, which is going to speed up your workflow. And also, if you're just looking at getting into VR development and maybe you don't own a headset yet, then there's also a great option to test things out. We'll leave this till later, but for now, we'll go ahead and import it. All done here, so we'll go ahead and close the Package Manager. If we navigate to the project window, we'll see we've got the samples, XR Interaction Toolkit, select the Starter Assets folder. You'll see here we've got the demo scene. We'll go ahead and open that up. So here we are in the demo scene, and this is going to be great for just showing you the capabilities of the XR Interaction Toolkit. You have areas where it shows you how you can grab objects and the various ways that they can be grabbed. You have poke interaction examples, gaze interactable objects, an example of how you can interact with the UI in VR, and some climbing as well. So this is definitely a good place to start. It gives you the opportunity to go through the hierarchy and see how these things are put together. We will be starting a scene from scratch in a second, but let's just jump into the scene actually in VR in the editor. editor and have a look around and have a look at some of the VR features. Here we are in our demo scene. You can see my headset's being tracked, my controllers are being tracked too, along with the ray interactors, which are the white lines you can see coming out from the controller. And using the left thumbstick, I can navigate around. And whilst holding the thumbstick up to move, where I look is where I go. And you can see when I move, I get a black vignette around the edge of the frame, and that is the tunneling vignette, which is designed to reduce motion sickness in VR. On the right controller, if I use the thumbstick, left and right, I can do a snap rotation, and pressing up on the thumbstick will allow me to activate the teleporter, where I can use the teleportation anchors to snap to specific areas. And it's these areas that you can move to in the scene that teach us how various objects within the XR Interaction Toolkit work. For instance, this area shows us how we can grab objects and the various different movement types. For instance, we have velocity tracking, where it collides with objects in our scene. And then on the other side, we have an object controlled by kinematic movement, which will pass through 3D objects in the scene. Here we have some examples of the poke interactors, and you can see on the controller we've got these little spheres on the end of a cylinder. These are our poke interactors, and these will allow you to touch these buttons inside the VR world. Moving over to the gaze interactable objects, you can see if I look at this cube, it will respond by showing me a sphere. And next to that, we also have a couple of different other modes, such as gaze assisted and gaze select and auto deselect, where if I look at it, it will change to hovered and then selected. Next, we can move over to our UI section, where you can use the ray interactor to control various elements of UI. So using the trigger on the controller, I can point at the slider here and move it left and right. But what's also cool is you can reach out in the world with your controllers that contain the poke interactor and actually press on the UI within the 3D space. And lastly, in the scene, we've got some climbable objects, such as this ladder here. So you can reach out to the rungs of the ladder, you'll see them highlight, we can then grab them and then climb the ladder as we would expect to in the real world. So there we have the demo scene, and it gives you a good idea about what functions are available within the XR Interaction Toolkit. But whilst this scene's great, what we want to do is be able to build our own scene from scratch. And we're going to be leveraging the XR Interaction setup prefab from this scene because it contains all the necessary VR components set up ready for us, which is going to speed up our development process. But we can go through this in more detail in the next section. So I'm going to go ahead and create a new scene, and it's just going to be a basic URP scene. Go ahead and create. And then we're going to drop in a quick floor, so we've got something to see what we're standing on. We'll go ahead and create a 3D plane, call it floor. We're going to use some of the XR Interaction Toolkit's prefabs in order to speed up our development. We want to drop in now our XR interaction setup into this scene, which is the prefab that contains the tracking for the headset and the controllers and the setup for the locomotion. And we can do that by going to our samples, XR Interaction Toolkit, click on the prefabs under starter assets, and we're going to drag and drop in our XR interaction setup. That's going to place it in our scene there. We can bring it up, and we'll go ahead and delete the main camera because we don't need that in our scene. And then this is now has given us what we saw in the demo scene, which is the rig set up ready for us to go. We've got the input action manager set up with all the actions assigned. We've got the event system, which allows us to listen for input system UI actions. And then we've got the XR origin, which contains all your components for tracking your controllers in your head and also the locomotion system as well. And if you want more information on some of the game objects in here and their components, then check out the ebook, which goes into a deeper dive and breaks down what each one of these does and how it works, and will give you a deeper understanding about what's going on. But for now, we've got our XR interaction set up in the scene. We're going to need to do a little bit of set dressing. We're going to need to create a couple of 3D objects that is going to assist us in grabbing. We'll start off by making a table. So we're just going to create a 3D object and we'll create a cube. This is going to be our table. Put it at 0. And then we just want to manipulate that a little bit just so we've got something to put our grabbable objects on. Call it table. And if you're familiar with packages like ProBuilder, this would be great for this, so you can rapidly create a prototype 3D scene. I'm just going to use some of the default primitive objects for the sake of the tutorial. Let's give this a little bit of color. So I created some materials in advance. So we'll go ahead and put our floor in and put a material on the table. Now we're going to think about the object that we're going to pick up. So I'm going to create an empty object, and I'm going to call this grab object. And I put it at 0, 0, 0. And inside there, we're going to create another 3D object. We're going to put a sphere. And it's going to be quite big because it's its default scale. But let's say we want it to be 20 centimeters across. So we go 0.2, 0.2, 0.2. Now we can see our object. I'm going to select my parent. I'm just going to place it on top of the table. Now the reason I've placed my sphere inside a empty game object is because as you're prototyping your VR games, you might not have the artwork ready, in which case you're going to be using prototypes like this. You don't really want to be putting all your scripts and components on your art asset because it makes it difficult then later on to change it, because you then have to copy all the scripts across to your new artwork. So if you put your artwork inside an empty game object, you can then put all the components on the parent. So to make this object grabbable, we're going to be clicking on add component, and we'll go to XR, and we'll just start typing grab. And we'll see we have the XR grab interactable popped up in the list. We'll go ahead and put this on our object, and you see it's going to add in the rigid body and the XR grab interactable component as well. We need to tell our XR grab interactable about the collider that is going to allow grabs to happen. We've got a collider on our sphere at the minute, but again, this is on our artwork and it may change later. So we could create another empty object in our scene. Let's say we just wanted to use the sphere shape of a collider. We could go ahead and create a 3D object, which is our sphere again. Remember, our object was currently 20 centimeters across, so we'll change it to 0.2, but we only want to use this as the collider. So we'll rename this object as collider, and then we can remove the mesh renderer and remove the mesh filter. So now we have a separate collider that we can again change later, depending on the shape of our game object that gets put in here. And back on our parent object where we have our XR grab interactable, we could go ahead and drop our collider into the colliders list. So this is the collider that's going to be included when selecting and interacting with this interactable. If we just left that empty, then what will happen is the XR grab interactable will look at the child objects and use those colliders. So at this point, this object is now grabbable inside virtual reality. It's going to be using the movement type of instantaneous. So when we grab it, it's going to track our controllers, but it's going to collide through objects in the game world, which is something you may want, and that might be okay for your game. We also have velocity tracking, which applies the velocity and angular velocity of the user's input device. This means that the object will continue to move according to the speed and direction in which the controller was moving at the time of the interaction, and also allow it to collide with elements in the VR world. And then lastly, we also have kinematic. And in this method, the object follows a set of physics rules, but without considering external forces like gravity or collisions. So I'm going to set mine to velocity tracking so it can collide with the table. And then we can test this out in VR by clicking on play in the editor. Here we are now in VR because we're using the XR setup interaction prefab. We have all the functionality as we did before in the demo scene. So I can use the controller here to distance grab the sphere on the table. And as well as the distance grab, we've also got the ability to grab it directly with the controller as well. So it's very quick and easy to set up the grab interactable. And you'll notice when you look through here that there's many more features you can check out. A great one is the attach transform. So if I wanted to grab the sphere in a very specific location and orientation, then I can create a transform inside my object, which would be the grab point, and I would assign that transform there. So maybe like the handle of a gun or something. And available to us are the interactable events, which we can tap into to create custom functionality. So we have events for when it's hovered, when it's selected, and when it's activated, all sorts of events that we can use to create custom functionality. So that's how easy it is to create an object that can be grabbed. In the next section, let's have a look at creating an area where we can place this grab object, leveraging the power of the socket interactor to create that interaction. First of all, I'm going to need to create some artwork for my socket interactor. So I'm going to go to my 3D object, and this time I'm going to choose a cube. I'm going to move it into position on top of my table and make it the size of a little platform on which this sphere can sit on. So we'll go ahead and make this a lot smaller. There we go. So this is now my socket interactor. Go ahead and give it a material, and I'll go ahead and rename it socket art. Now remember, this item could actually change later on. I'm going to create a parent. Let's go, so we'll create empty, and we'll call this socket interactor blue. Go ahead and drop it inside our artwork. If we go to position and go 0, 0, 0, it's going to center it in the middle of our artwork where we can pull it out, and now we can drop in our artwork inside that object, and everything is nicely centered. Then on our socket interactor blue, we're going to go to add component. I'm going to start typing socket, and you should get the XR socket interactor pop up. We can now click this, and it will apply that as a component. This socket interactor is part of the XR Interaction Toolkit, and it's going to act like a holder or a slot that catches other objects. Essentially, it allows objects to snap into place and stay attached until they are removed. And this is some functionality that you see in a lot of games, not just VR, but in VR, you might be challenged with finding an object like a key, navigating to a lock, and then placing that key inside a lock, and then that would cause something to happen. In the XR Interaction Toolkit, the tool that allows that to happen is the socket interactor. And the way you control whether something is allowed to go into the socket interactor, you would look at using the interaction layer masks. First of all, in order to allow the interaction to occur between the grabbable object and your socket interactor, you need to put a collider onto your socket interactor to know when that collision has occurred. So we're going to go to add component, and we're going to add a box collider on in this instance because it matches the shape I can see it's quite big, so we'll go ahead and make it about the size of the cube we put in there, which was 0.3, and we'll go 0.3, 0.3 just to make it a square. And then we're just going to bring it up a bit so it sits above our little platform. So as soon as our sphere enters that socket interactor, as soon as the sphere goes in here, it's going to allow the socket interactor to grab hold of that object once we release. And then on the box collider, we just need to make sure we check is trigger. Now what will happen now if we put our sphere inside the box and we release, it's going to be grabbed by the socket interactor. So let's jump into VR and see this in action. Now if I reach out and pick up the sphere and place it inside the socket, you can see we get a highlight of the object. Then I can release the sphere and it will snap straight to that position. You can actually specify a custom position for the object to snap inside the socket interactor. So let's take a look at that now. Earlier in the video, we saw the XR Grab Interactable and its attached transform. The socket interactor has one of those too. So to finish off this interaction, we could go ahead and create an empty game object, and we can call this attach point, and we'll bring it up a little bit. The sphere sits there and looks like it's hovering. The center of the sphere will be around there, so just bring it down a touch. Back up to our socket interactor, we can drag and drop our attach transform into the attach slot. Let's play again. Now you can see that our highlight has actually moved to where our attached transform is. Now when we release, our cube actually moves to that new position. And then just like the Grab Interactable, the socket interactor contains the Interactor events. So one on hover and on select. Select being when the object is placed inside the socket interactor, and hover being when your hand is reaching in. So you'll be able to then leverage these events and create custom interactions. For instance, if this sphere was a piece of a puzzle that required placing inside a certain area in order to grant you a reward, then you could use the select entered to control that interaction. But at the moment, this socket interactor accepts everything that's going to be placed inside of it. If this was a puzzle, you would only want one certain object to be placed inside. So what we can do is we'll give our sphere the blue material, select our sphere in the scene, we'll duplicate it, and we'll move it over. And let's give this a better name. So we'll have red sphere, and we'll have blue sphere. And we'll do the same for the socket interactor. We'll duplicate that, move it across to the side, and we'll call this socket interactor red. Let's create a quick material. I'll give my red interactor the red, and my red sphere the red material. So now you can quickly see how this puzzle may work. You would only put the red sphere inside the red socket interactor and the blue sphere inside the blue one. But at the moment, you could put the red in the blue and vice versa. There's no controls there yet. What we could do is we could go to our sphere. Under the XR Grabber Interactable, you see we have the interaction layer mask. You can use this to assign our grabbable object a layer. So we could go and add a layer to this. You see we've got interaction layers. We could put this on its own layer, and we could call this red interactor, and then go back to our red sphere and then set the interaction layer mask to red interactor. You'll see it's highlighted everything, but we don't want that to be the case. So I'll quickly set it to nothing and put it back on red interactor. And then on my red socket interactor, we'll put it on the same layer mask and put it on nothing and red interactor. So now only an object on the same interaction layer mask will be able to go inside this socket. To make the socket give you that visual, create a green material. And on my red interactor, I can assign the red to can't hover mesh material. And if something can go in there, we'll assign it the green. So now that we've got our objects assigned their interaction layer masks, we do just need to tweak our XR interaction setup a little bit. We need to be able to tell our hands that it can pick up the red interactor layer because we've effectively added a layer. So we go to our XR origin and find our controllers. So we've got the right controller here, and it's direct interactor. We can see we've got the interaction layer mask set to default, but it's not checked as that we can select the red interactor. So we'll mark it as red interactor. In fact, it should be everything that your hands can interact with. So we'll make sure it's everything. And the same for our ray interactor as well. So we can, if we want to do a distance grab, and put that on everything. You may want to change this later if you don't want your interactors to interact with a certain layer. You can use your interaction layer mask to turn it off. And we'll just do the same for the left controller. Find the direct interactor and make sure it's on everything for now. And the same with the ray. Make sure the red interactor is ticked. Let's test this out in VR. I can pick up my blue sphere, and that goes inside the blue one. Let's see if it'll go inside the red one. No, it doesn't, because it's recognized that it's not on the correct layer. If you try and use our red one, we take it to the blue socket interactor. Blue socket interactor is not set up yet for its interaction layer mask, so it should be accepted. But let's see now if the red socket interactor accepts the red sphere, given that they're both on the same layer. We'll place this in, and you can see there that the highlight is showing. We haven't set the color of the highlight yet. but it's recognized that it is a valid layer and will be acceptable to the socket. So now if we wanted to set our blue one to only accept the blue interactor, we'd do exactly the same. Interaction layer mask, add a layer, call this blue interactor, put it on nothing, and then select blue interactor. So this now only accepts interactable objects that are on that layer. So now we can go ahead and we can give our hover mesh material the green material, so it shows green. And the reason it showed grey when we had the red one was probably because we didn't actually make our material green. So make our material green here. We'll put our blue sphere on exactly the same layer. So now it's on the blue interactor layer, and we'll just double check our hands to make sure that that's gone on okay. So our left controller, direct interactor, still set to everything. You see blue interactor stick, so that's good. Quick test in VR. You can see here we're getting the green visual to indicate it's a valid socket. And then we also get the same with the red. But then if we try and swap them, you can see that the interaction layer masks don't match up, so nothing happens. So hopefully now you can see the power of this socket interactor and how it can be used to create puzzles within your VR game. And for this next section, let's have a look at how we can create some teleport points that will allow you to navigate around your VR world and place the player exactly where you need them to be. We're going to be using the functionality of the XR Interaction Toolkit to create our teleportation. And with the XR Interaction Toolkit, there are two ways in which the user can navigate the scene. We can give them the ability to teleport anywhere within a certain area, and that's called a teleportation area, or we can allow them to teleport to a very specific location, and that's called a teleportation anchor. Both are very easy and quick to set up. And we're going to have a look at the teleportation anchors. So we're going to create an empty game object in the scene, and I'm going to call this teleport anchor. I'm just going to put it at 0 for a second. And on this component, I'm going to add the teleportation anchor. If you don't see it, just start typing teleportation anchor. And now we can see it's put a volume in the scene, so we can place this anywhere around, and the user will be able to utilize the function of the provided XR interaction setup, which includes the locomotion system. And you can see it's got the teleportation provider already set up for us, part of that prefab. So then when we push up on our right thumbstick on the controller, it'll activate the ray, and then we'll be able to point at the teleportation area. And then when we release, it will move us to that location. But to help us see where this is in our scene, we're going to go ahead and create a 3D object, and we'll just make a cylinder. Again, let's put that at 0, and we'll scale it down like so. And then we can put it inside our teleportation anchor and just make sure it's in the right place. Now with this, you can point the user in a very specific direction. So if we wanted them to be facing this way, then we can use the forward direction and the teleportation configuration. If you do want them to face a specific way, we can say target up and forward, and then we can aim our teleportation anchor whichever way we like. So we've just placed this over here. Again, teleportation anchor, it comes with the interactable events, so we can create some custom functionality by plugging into these events as and when required. To conclude the setup of this, we're just going to make sure the interaction layer mask is just set to everything for a second, because we want to make sure it interacts with our rays. And from here, it should be good to test out in VR. So back in play mode, I've still got the ability to move around with my left thumbstick, and I can turn with the right stick with the snap turn, and then push up on the thumbstick to activate the teleporter. Then as soon as the ray enters the teleport area, the ray turns green, indicating this is a valid teleport point. You've also got the directional indicator showing you which way you're going to rotate when you go into the teleport area. And if you release the thumbstick, you will teleport to that position. We saw there that my activator was hovering slightly above the teleport anchor, and that's because of the collider that's on that cylinder. At the moment it's using a capsule collider. Go ahead and remove that capsule collider. Let's go, we can use a box collider on there, which fits that object much better. So when we hit play, and I push up again on my thumbstick, you can see that it's now sitting on the surface of that teleport point. And then you can go ahead and create custom artwork for what's displayed as your teleport point. At the minute we just got it to as a cylinder, but you can have whatever you wanted to make it more visual and engaging. And then all you'd simply need to do at that point is to create a prefab of your teleport anchor if you wanted to, and then you can just duplicate them around in your scene to allow the player to move around to very specific locations. And this might be a great way to show players where important aspects of the environment might be, gives them a good indication of where they need to be and what they need to interact with. And as you can see already in this video, I've had to hit play a couple of times now and just quickly test that functionality is working. And when you're developing and iterating quickly, you might not want to put the headset on and off all the time. And that's where the power of the device simulator comes in. So if you need to navigate to the sample assets, and earlier when we imported all our packages, we brought in the device simulator, you can go ahead and just drop this straight into your scene. And then now when you hit play, you can see I'm now using the device simulator. I'm able to look around with my mouse as if I was looking around with the headset, and I have a panel on the left which gives you all the controls and all the keys required to activate the different buttons on the controllers. So if I wanted to try and pick up the sphere here and place it in the socket, I can use the TY to toggle my controllers. See, now I'm moving on my left controller, and you can see in the pictures the button for grab is G, so I can go ahead and pick up my sphere and move it into my socket and then let go of G, and it's put it into the socket so I can test out my socket interaction. So then if you wanted to test out the teleportation anchors, we could look at one over there, press Y so we can use the right controller, and then to activate our up stick, we can just hold down W and then we can move around. You can see our teleportation anchor working there, and then we can release our key and then move. And at first this might feel a little bit slower, but then you soon get used to the keys and which ones you want to press to activate different parts of the functionality. But it just allows us to test very, very quickly. If you wanted to allow the player to teleport anywhere, then rather than a teleport anchor, you would use a teleport area. And we can turn our floor here, so this entire blue square we can make available to the player so that they can teleport around anywhere they want to. In order to do that, we can create an empty game object. I'll call this teleport area. Make sure it's at 0, 0, 0. And I'll go ahead and drop my floor into the teleport area. And then on my parent game object, I can go ahead and add the teleport area component. Set my layer mask to everything. You can see we're using our device simulator here. I'll toggle the right controller. You can see now I can teleport anywhere in my level. So that now gives us 3 methods of moving and navigating through our scene. Movement on the left thumbstick, where you can use the axis to move backwards and forwards and use your head to steer. Or we have our teleportation anchors. Now we have our teleportation area, which is allowing the user to go all the way around our little level here, whilst also maintaining some very specific points using the teleport anchors. So up till this point, we've managed to create objects you can grab and place into certain areas with logic about what can go in which socket interactor. We've also taken a look at the different ways of navigating the scene. We've got our continuous movement controls on the thumbsticks. We've also got the teleport anchors and the teleport areas. And we've done all that so far with no code, all just using the built-in features of the XR Interaction Toolkit, which really showcases its power in very quickly developing VR games. The fundamentals of navigation and grabbing are all there for you, and then you can just tap into the events of the objects that you want and create custom functionality from there. So we've got our little demo scene here. Let's take a look at how we can now build this to our headset. So to get started, the first thing I'm going to do is remove the XR device simulator from the scene. And then if we go back to the file and bring up the build settings, and you want to make sure you're on the Android platform. If you're not, you can go ahead and change it. And then you may need to revisit the project validation after you've done that, because there may be some project settings that will need fixing. You can hit the fix all, which will take care of it. Also need to make sure that your device is plugged in and it's in developer mode, and then you can select it from the run device list, and also that the scenes in build is the current scene that you're in. The last thing we need to do is a quick adjustment to our player settings. If we go ahead and click on the player settings, it'll bring it up under XR plugin management, select Open XR, and we just want to make sure that the Meta Quest support is ticked, because I'm building for the Quest. I'm going to see here we've got a warning, which we can go back to the project validation, and you'll see here it's warning us that the screen space ambient occlusion render feature results in a significant performance overhead. This one isn't able to be fixed, but if we wanted to take care of that, we could go to our graphics, and where it's got the URP high fidelity renderer there, we can double click it, which will select it in the project, and then you can go to the high fidelity renderer. This is the current renderer that we're using, so we can go ahead and remove that if we wanted to. And in fact, at this stage, you could swap out the current renderer that's being used. So up in the graphics, we can change that to the performant. So we can drag and drop the performant in there and hit continue. And then under quality, we can change it to performant for our Android, which is going to use our performance settings, which will be more optimized. And we can always increase quality and detail as we progress with our game. But I always like to start off with the performant renderer. So once we've added the Quest to the OpenXR settings and we've changed to the performant renderer, we can now go ahead with our device connected, go ahead and build and run, which will be prompted to save it, and then it will build and deploy to the headset. So here we are in VR. You can see I've got my controllers all being tracked. My headset's being tracked as well. And you can see, just like in our game, we can grab objects and put them in our socket interactors, and then we can use the thumbsticks to teleport around the scene. Using the teleport area, we can go anywhere we want to, and then using our left controller, we can use the continuous move and where we look is where we go, with the tunneling vignette as well. So I really hoped you've found this tutorial useful. As I mentioned earlier, there is an ebook available that goes over a lot of the components used in the XR Interaction Toolkit and VR development that explains it all in greater detail. Feel free to take a read of that one. And hopefully you've seen the power now of the XR Interaction Toolkit and just how easy it is to create the basic functionality with absolutely no code. Thank you very much for watching.